My name's Doug McLeod with PCT International, and today we're going to talk about signal leakage and F connectors. The number one cause of signal leakage in our industry are loose F connectors, and they can come loose for a variety of reasons, including temperature changes and vibrations, which occur even inside the home, as well as if the customer does not tighten things down properly when they're doing a self-install. All of these loose connectors will allow signals to leak into and out of our networks. Historically, this has been an issue for the aeronautical band, but over the last few years, 700 megahertz LTE interference has become a genuine issue. Going forward, we now have 600 megahertz 5G coming online and Internet of Things services, which are going to operate over a wide range of shared frequencies with our networks. All of these are adding more potential sources of interference, which means our shielding effectiveness is even more critical. Within a connector, in order to maintain shielding effectiveness, I have to make sure that the mating face on the F port is in physical contact with the mating face on the F connector. If they are not in physical contact, we can lose as much as 20 dB of shielding effectiveness. We need to keep the metal-to-metal contact to maintain shielding effectiveness. Lock washers are used to retain torque and keep nuts from coming loose. PCT has added a lock washer in our patented connectors to keep the connector from coming loose. The only good connector is a tight connector. But we do know that customers don't tighten things down properly and they can leave a gap between the faces. The interesting thing about the lock washer and the PCT connectors is it also helps to keep the faces in contact when loose, stopping signal leakage. No other connector on the market can do that. The demonstration you are about to see uses light to show how the lock washer stops signal leakage even when PCT connectors are left loose. Light and RF are both electromagnetic energy, just at different frequencies. If light can leak out, so can RF. And if RF can leak out, RF can also leak in. As this demonstration shows, the PCT connectors are the only F connectors that can maintain shielding effectiveness even when loose.
Okay, today we're going to do a demonstration that shows the enhanced shielding capabilities of the PCT torque retaining connector, the TRS6 LMG. What we've taken is we have a barrel splice F81 here and an F connector here where we've done a cutaway section so you can see the shielding capability of the connector. So if we back off the F81, we can see light coming between the F81 and the connector flange. This area is very important to stay tight to deliver the best shielding performance. We find that shielding performance with all connectors when they're loose is very poor. So what we're going to do here is we'll tighten this down, and we see the light disappears, so your shielding performance is good at this state. So we'll tighten this down at finger tight, and of course you see that you have a very good tight shielding connection between the two. So if we start to back this off, loosen it in reverse rotation, you can see we're turning it quite a bit. There's still no light showing through there, so you still have good shielding integrity between your F port and your F connector. So we're going to turn it back a little bit more, and we can just now start to see the light. So as you can see, it takes quite a bit of reverse rotation before the signal starts leaking between the connector and the F81 barrel splice. Okay, so to further demonstrate the shielding performance of connectors, here we have, we're going to call competitor A, and we're going to show the same type test for shielding performance. We're going to take and tighten down the F81 into the connector until the light disappears. We'll go ahead and we'll tighten this down to finger tight, just like we did the PCT torque retaining connector, and we're going to back it off. The light is already showing. As you can see, it takes very little reverse rotation before the signal starts leaking between the F81 and the connector post flange. Okay, here we have another connector. We're going to show the shielding performance as well. Again, we're going to tighten down the barrel F81 into the connector. There you can see that you have a sealed connection. There isn't any light shining through. We're going to go ahead and tighten this down as much as we can with our fingers. And we're going to do the reverse rotation and see just how far it goes before we see light. We're already seeing light. So as you can tell, it takes just a slight movement of the connector before you lose your shielding performance.